Okay, welcome to the last lesson of this unit on series. Okay, the nice thing about this lesson is most of this we've gone over in some way, shape, or form before. So some of the formulas are a little new. We are using a different book to talk about this. Remember, the conceptual stuff does not have to be written down. I hope by now we're in the last lesson. We've already had one notebook quiz. You have a feel for what it needs to be done and what doesn't. So we're using the black book for series because the purple book really didn't have a good lesson on it. So conceptually, what is a series? A series is a summation of a sequence. So we already have dealt with the summations, we just haven't called them series. So just realize that conceptually a series is summation. So there are different formulas. These may look similar to the formulas you've used so far. They may be just slightly different. So for arithmetic series, these are the formulas for finding the summations. Okay, so this is arithmetic sequences. To find the summation of them, when we find the summation of them, it is called a sequence. Geometric. Okay, here's your formulas down here. I will not be requiring you to memorize these. Okay, I will give you these formulas. On most tests, I'll give you a formula sheet of some kind. This one will have these formulas on here. So this is a geometric sequence to find the series. Now, the one thing I want to point out is when you are finding a specific term in a sequence, it will be written as a U. If you are looking for a summation or a series, it will be asked for in an S. So if I ask for Sn, I'm asking for the series or the summation. If I ask for a Un, I'm asking for just the term itself. Okay, what is the 20th term, the 30th term, whatever. So let's go ahead and look at some examples. All right, so first of all, before we get into the arithmetic sequence and the arithmetic series, we're going to talk about just doing summations. All right, you've done these already. There's a few more in this section I just wanted to talk about. So there are some rules that you can follow to make your life just a little bit easier. It says if I have, if I'm changing, if I have a series where I'm adding two things together, I can split them up. All right, and I can add the first term, I can add them up, and then I can add up all the last terms, okay? Likewise, if I have a constant, okay, and it's multiplied by my term, I can take it out and just multiply it in the end once I have the summation. So you'll notice that that's what this is. And this also says if I have a constant that has no variable, I just take that constant and I multiply it by n. So we're going to use all of these rules. You may do this the other way if you would like, by simply, the way we've done it so far, plugging in each number and solving that way. But I'm going to use the rules just so you can see how they work. So, so we're going to split this up first of all. K equals 1 to 4, 3k plus k equals 1 to 4 of negative 5. Okay? And then we're also going to take this out 3 times the summation. K equals 1 to 4 of k. All right, so what this means is that I'm going to take 1 to 4, k itself is added up. So 1 plus 2 plus 3 plus 4, and I'm going to multiply that all by 3. Okay, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, times 3 is 30. Okay, and now I'm going to take this number here. Remember, this says if it's just a constant or a number that doesn't have a variable, we just multiply it by the n value of what's on the top. So negative 5 times 4 is negative 20. 30 plus negative 20 is 10. In some ways, I don't know that it's necessarily less work than before, but it's just another thing to be aware of. So. All right, so here's a couple of examples for you to try on your own. You may use the new rules if you would like. You don't have to. Okay, these are just, something interesting, something new, a different way to do it. All right. Here's your solution. Example number 2. Okay, now we're going to get into the arithmetic series. Example 3 will be geometric series. So here are my formulas, okay, and I want 20 terms. So I can either do this in one of two ways. I can either use the first formula. If I use the first formula, I must find the explicit formula and I must find the 20th term. If I use the second formula, I do not. So I'm going to use the second formula. So in this case, I have 20 over 2 times 2 times u1 is 3, okay, plus n, which is 20 minus 1, times d. Now d is my common difference. If I look at this, my common difference is 4. Okay. At this point, I would use a calculator to solve the rest of that. So find the answer. I did use a calculator to solve this problem. And I got 800 and you could use the other formula if you want to find the explicit formula and do that. You don't have to. My opinion, my personal opinion in anything, is that if there's an easier and better, okay, it can't just be easier. If an easier and better way to do it the easy way. You know, sometimes if you want to make, you know, sometimes the easy way is not the better way. But in this case, the easy way works just as well, if not better than the better way. So, all right, practice 2. Pause the video, do the problem. Here's your solution. Remember that you don't have to have done a solution the way they did, as long as you have the answer. Example 3. Okay, again, we're sitting in a situation where we have 2 different formulas. You'll notice they're almost identical. Okay, this one has r to the n minus 1 over r minus 1, and this 1 minus r to the n over 1 minus r. So these are almost identical formulas. So in this case, it doesn't really matter which one I use. So I'm going to use the first one. So first of all, I need to identify what my r is. So r is saying I'm multiplying everything by something to get to the next term. In this case, they're getting smaller, so I'm going to be multiplying by a fraction or a decimal. 12 to 6 is multiplied by 1/2. 6 by 1/2 is 3, so my r is 1/2. So my SN, my summation here, or my series to 10 terms, is U1, which is 12, times 1/2, the whole thing, to the 10th power, minus 1, over 1/2 minus 1. Definitely use a calculator, okay? Please do not, these kind of problems, do not try to do these by hand. You're going to be wasting a whole lot of time if you do them. So I did the calculator, I got a very long, strange decimal, 23.9766. All right. Practice number 3, okay? So this is your practice problem, pause, do the problem. There's your solution. Okay. And that is it.